appearing opposite in direction. So that means at a point on axis, they are appearing at some divergence like this. And I can say with the line of symmetry, geometrical angles appearing something like this. So what will be the resultant effect of these two DE forces? What will be the resulting effect of these two DE forces appearing at point P? This is happening for one pair of diametrically opposite pair of elements. So what I can do? I can resolve these two DE forces. I can resolve these two DE forces and it can be explained like this. Do you understand it or not? You might have again, see the application of the mechanics portion what you have learned in class 11 will be coming across several times. This is D. Can I write down two components of D? This is D cos theta and this one is D sin theta. Do you understand it or not? Tell me if you find any problem, then ask your doubt. This is D cos theta. This one is D sin theta. Right? Is it okay? The component resolution. So what we can find to the conclusion about these two forces because of one pair of diametrically opposite pair of elements at a point on axis, we can see the two diverging forces which are appearing like this. After resolution, I can get two components along the axis line and two components are coming perpendicular to the axis line. So do you think that these two equal forces, should they cancel each other? Two equal and opposite force should definitely cancel each other. So D sin theta will get cancelled out and these 2D cos theta will be getting added up because they are appearing same in direction. That means what is the conclusive things that I can write down? I will write down due to one pair of identical elements, of the ring, due to one pair of identical elements, one pair of diametrical, write down one pair of diametrical as well as identical, right? It is identical as well as position wise we are talking about. It is just because of those two elements which are appearing diametrically opposite. So due to one pair of diametrically as well as identical elements of the ring, net force on the plus one on the unit positive test charge, on unit positive test charge at a point on its axis can be given by 2D cos theta. Do you agree with me or not? Tell me. Do you understand the writing of this statement what I have done? So what we can see, for one pair of diametrically opposite pair of elements we are getting the net effect is 2D cos theta. So can we say that how many such diametrically pair of opposite elements can be there? How many diameters? First of all tell me mathematically how many diameters that we can think about in a circle. How many diameters we can draw? Suppose if you are given a circle and in a very simple question asked in a class or anywhere saying that please tell me how many diameters that you can draw, what will be the answer? See, sometimes knowledge does not get restricted with the chapter. So we are talking about the electrostatic, but it comes to the mathematical logic. Because if you understand the mathematical logic, then you can understand what we are supposed to do in the next step. Because that's why it is called the mathematics is the language of physics. Why it is called in this way? Why this word has been stated? Vansita saying infinite. Yes, correct. There can be infinite diameters that we can draw. No two diameters can intersect anywhere other than the common point, which is called the center of the circle. So that means if there can be infinite diameters, then that means I can make infinite such planes like this. These are three-dimensional geometry, and you need to visualize it like this. Don't think that, see, this is suppose the plane of the circle. This is suppose the plane of the circle, and think about the position of this chalk holder is the axis passing through the center from this plane, right? So now how I will explain you about one plane. Just a minute, give me some time. Yeah, this is one plane, right? So think about this diary. This is the plane on which I have drawn the circle. The position of the chalk is axis. Now I can take one line. This is one plane, and this plane will cut the circle at the one point upper side, one point lower side, right? So this is the plane on which this two lines are drawn. Like if I suppose now keep on rotating this thing, on every position of this, there is a common appearance of the chalk. That means axis lies on each and every plane. How many positions I can think about? Infinite. If I keep on rotating, I can make infinite plane position of this, right? This is the visualization of this actually. This is the visualization is happening here. So that's why we will get, that means due to, therefore now we will write down due to the total charge capital Q, we can think about infinite pair of diametrically opposite elements, right? Opposite elements means there can be infinite values of 2DE cos theta, isn't it? Because for one plane, for one pair of elements connecting them along with the axis, we get one plane. So for one plane we get the resultant effect 2D cos theta. How many pairs can be? Infinite. Each pair will result 2D cos theta. So to utilize the total charge appearing on the ring, we will get infinite steps of 2D cos theta. How will you add it? If you are asked to add 2 plus 2 plus 2 plus 2 continued so until infinite steps, what will be the result? So see, now I will say that to get the total, to get the net electric field, at P, we need to integrate, right? Integrate the value of 2DE cos theta, right? Because we are supposed to, logically Camilla, we are supposed to add 2DE cos theta for how many times? Infinite times, right? So whenever we are supposed to add a number for infinite times, we have to follow the addition by the process of integral calculus. Integration is the part of calculus where we add the small quantities and we assemble them to make a bigger quantity, right? So we need to integrate 2D cos theta. So this means this implies that total electric field at P can be obtained by integrating 2dE cos theta. Now this is the mathematical part.